All right. Well, hello, everyone. My name is Mark Thomas. I'm Executive Director here at DMSC, and we're very pleased to be putting this webinar in front of you based on the registration count we've seen. That there seems to be a lot of interest on this topic. And today we've got two gentlemen. We have Daniel Campbell from Rubypoint and Evan Kessick from Elysium. I think you'll find both these guys have a lot of expertise and experience in the MBE world, and so they're going to be talking with you today. So I'm going to step out, and Daniel and Evan, please go ahead. Just for the audience as well, on the upper right-hand corner of your screen, you'll see a little computer screen simulator with a question mark in it. Those are for questions. When you click on that, you can go ahead and enter your questions and then hit send. Those will go directly to the presenters, and they're going to decide whether or not to answer those questions right away, or more likely it will be held on until the end of the session. So you should be able to get your questions answered, and that's part of the whole point of this presentation. So Daniel, Evan, thank you for joining us today, and you've got the con.
Perfect, thanks. Yeah, so thanks for joining us and prioritizing this time over lots of other things going on probably in your daily lives. So today we're going to be talking about extending the digital thread with model-based characteristics and QIF. So my name is Evan Kessick. I'm the Director of Model-Based Initiatives at Elysium. I'm fairly new to Elysium, so joined in January, but not new to the industry. I have 18 plus years of experience in engineering and design, where a lot of that time I was doing implementing model-based definition and model-based enterprise. I'm also heavily involved with industry standards, so currently chair the Model-Based Enterprise Committee for ASME, and I also co-chair one of our new harmonization committees, and then heavily involved with the DMSC as well.
Yeah, my name is Daniel Campbell. I'm the president of Rubypoint. We provide consulting in the area of model-based definition, both from an end user perspective, also from a software perspective. I have a lot of background in the area of QIF. I've been involved with the development of QIF since it was just an idea. And so I'm very active with QIF and DMSC, and I've just been active in the area of model-based enterprise for 20 plus years. So yeah, excited to be here with you all today.
All right, so in the agenda for today, we're going to be splitting this up. So Daniel Campbell is going to walk us through some of the digital gaps that we have today between design and downstream consumption domains. He's going to talk about some of the enabling technology for model-based definition. He's going to touch on model-based characteristics and QIF in the context of model-based definition. I'll touch on the different types of characteristics, what a bill of characteristics is, how it's being used, and then we'll walk an actual consumption workflow stemming from the engineering domain, some technical data exchange, and then into our downstream consumption domains.
Great, thank you. So yeah, I'll start off just giving a little bit of background. I mean, we'll start very sort of high level and talk about some of the concepts, and then like Evan's saying, he'll get a little bit more into the specifics, the application level stuff later on. So let me start by just looking at what is the problem that we're trying to address. When we talk about model-based definition, for example, when we talk about semantic model-based definition, what is the problem that we're trying to address? I mean, it's basically that there is a wealth of information contained in your PMI or on your drawing right now, all your annotation metadata that's contained, it's authored in the product engineering space, but consumed in manufacturing and quality, or that data is required in manufacturing and quality. It's required downstream. And there's this big valley of death in between. So, what does that mean? You engage in, time draining meetings. There's a lot of guessing and assuming about what things might happening and poor interpretation of the annotations. PDF reports flying back and forth, spending a lot of time reading through those. Sometimes if you want to get clever, you create these Excel documents that could be very, very complicated and over-engineered, and that's the solution to passing data back and forth. Overall, I think we can all agree that there's a big problem with passing this data along. First of all, there's a lot of manual handling of these characteristics at each stage, and that's just a huge burden in terms of, the time that it takes. Another really big thing is the inconsistent processing of characteristics. Since it's just basically typically a PDF that you're looking at, different people will interpret them differently, which is never something you want in manufacturing, obviously. And then another big problem, especially as we enter the digital age, is just that there is no visibility to these characteristics, to those annotations on your drawing or your part across the enterprise. It's sort of a visual artifact that gets consumed by a human engineer at different points of your enterprise. So this is the problem that model-based definition is trying to solve. And so that's why we talk about, digital thread, yeah, great. Model-based definition, great. Characteristics. This is why people are starting to really talk a lot about characteristics, because people are realizing that really is the essence of what the data is that we're trying to track. So to take a step back and think about this digital thread, what is the digital thread? It's a term that's thrown around. And the core of the idea is that we have very, very, very good point technologies in narrow domains. I think that's clear. There's very good software packages that do various different things in each of these different domains. And so the digital thread, what is that really about? That's about trying to connect all of these solutions so that they can talk to each other, so they could benefit from each other's knowledge. That's really a large part of what the digital thread is about. And that means across domains, from engineering through manufacturing through quality. And so, what's the enabling technology for us to get there? Digital thread is just a high-level idea. You don't implement the digital thread exactly. That's something hopefully you realize. So what are the technologies that you have to implement to get there? So MBD, that's really what we're talking about, I think. We want to have model-based definitions so that we can have some semantic structure around our annotations. So it's not just a visual decoration for a human being to consume. So certainly model-based characteristics or model-based definition, semantic or machine-readable model-based definition. But ultimately, to get down to an even more detailed level, what are we really talking about is characteristics. So, what are characteristics? Characteristics are each of the atomic units of data that you'll find in your MBD or in your drawing. You have all these annotations, but each of them boil down to something. An experienced engineer can look at a drawing and boil that down to a first article inspection report, for example. So that's the task of extracting or understanding what the characteristics are that are found on a given drawing or MBD model. And so I think this is an important takeaway. The idea of semantic characteristics, that's the core building block for the digital thread. And I think this is an important thing that industry is really starting to wake up to. So now I think we know what technologies we need to start taking seriously in order to implement this digital thread concept. And so how do we do that? I think the key to doing this is understanding that there are actually good technologies and good standards out there that allow us to implement these techniques. And so don't think about this in the abstract. Look at use cases in your own enterprise where you consume characteristics, and think about how you can use some of the tools and some of the standards that are out there in order to accomplish what it is that you're looking for. That's a little bit of background, I think, again, just thinking about characteristics. This is, I think it's a very important concept for people to start to really grab onto. which is why it's timely that the DMSC has released this standard, which is the first standard in this area on this concept of model-based characteristics. So the idea of what this standard accomplishes is it gives users, it gives manufacturing enterprise a way of thinking about how do we track characteristics, putting IDs on characteristics so that they can be tracked across your enterprise. In addition to the characteristic itself, what's some additional metadata that might be attached to the characteristic that should be tracked? Basically what it does is it provides the framework where characteristics can start to be thought of as business objects across your enterprise. Something that could fit into, to a business software context, just like you might think right now about parts in terms of how you look at parts within the context of your PLM system. And I think one thing to point out is that, model-based characteristics, this standard is really kind of meant to address is the idea of model-based. Model-based definition, 3D annotated models. But actually the principles that are discussed here are applicable to 2D drawings as well, to traditional 2D drawings, if you want to start thinking about characteristics on 2D drawings in this way. So what I'm going to do is I'm going to give a little bit of background about what the model-based characteristic standard is, and then give you the resources you can go and download it yourself and check it out. So what we're talking about is this idea of these characteristic tags, these characteristic IDs. Sometimes they're known as balloons. Traditionally they're known as balloons because you take a piece of paper and actually start marking it up with a pen, 763, 764, 765, etc. But what we're establishing is a framework by which we can start to identify what these characteristics are, how they get tagged, how they are discussed from one software to another. And so that's really one of the core ideas, is the way that characteristic IDs are assigned. But then we get into different augmentations that could be added to the characteristics as well, and establishing a framework by which you could start to apply this extra bit of metadata. And so, like I said, the core thing is this balloon, and this is called the product characteristic tag in this case. It has this PC prefix, which is optional, but it stands for product characteristic. And this is the core ID for tracking this characteristic. This might be a human readable characteristic, 41. That ID should be unique within the part. I think that's obviously very important. Also, the standard does discuss the idea of the use of machine readable IDs. You sometimes maybe have heard of as UUIDs, which is a very very robust standard for generating unique IDs that can be assigned to a piece of data in software. So there's a framework for mapping UUIDs behind the product characteristic tag as well. But that's kind of the core element that keeps this entire characteristic tag together. Next, we have the product requirement association. And so really what this is doing is this is tying together the product requirement that was the source of this particular annotation. So, maybe this annotation is a size tolerance on a hole, and that exists because there's some critical design aspect of this part where that diameter needs to be controlled for some reason for the function of the part. That might be annotated somewhere in a requirement system. This allows us to establish that link between the characteristic on a model-based definition and the system requirement that originally drove that requirement. This could be useful for example, design FMEA analysis. It could be a very useful piece of data. Next, we have this idea of criticalities. So this, generally you might see this as something that's high criticality or medium criticality or low criticality. That's the idea of what this is trying to, or this is a piece of extra data on top of a characteristic that could be added. There are a few different types. There are levels, like I said, high, medium, low, where it's an ordered set and you choose one. There's also category, where it's an unordered set and you can choose one or more maybe you could say this is for safety and for regulatory compliance, for example. And then additionally, there's even this caveat, which is just free-form text that allows product definition to specify a little bit of extra information related to the criticality. The final piece of data, metadata that could be attached, is this verification plan requirement, which provides a method where we can say a little bit about the way that this particular characteristic should be inspected. That means, for example, you could specify a method like CMM or caliper or something like that, but also the context. You can specify, well, in FAI, we're going to inspect it with CMM, but once we go into production, we're going to use some other method. Also the sampling plan, maybe we're going to do 100% inspection. Maybe it'll be, some lower inspection frequency, only some number of samples per batch, something like that. But that's the essence right there of what the model-based characteristics standards tries to talk about. Just give a framework again for that core product characteristic tag, and then some of the metadata that can exist around that, so that we could start to look at individual characteristics on the part and identify them individually and speak about them as their own entity. If you want to find out more, please do go on to the DMSC website, QIFstandards.org, and you'll find a way to be able to download the standard and check it out. The next standard area I want to talk about just briefly, especially in regard to how it ties to making the ideas in MBC a reality, is QIF, which is another DMSC standard. Again, you could find QIF version 3. You could download it from the website. So QIF, this is a scene I think that many people have seen. These are the different application areas of QIF. At the core, we have the library, but then there's an application area for model-based definition, for plans like inspection plans, measurement resources, the ability to characterize what your measurement resources are, rules for establishing maybe best practices or templates that you might want to apply. DMIS is not part of QIF, but it's very much harmonized with QIF. It's also governed by the DMSC, so it's included here. QIF results for collecting inspection data, and then QIF statistics for specifying statistical methods for analysis of the data and so forth. But at the core, again, we have this library. This is really important from a model-based characteristics perspective for two reasons. That's features and characteristics. So this is a core part. If you want to understand what QIF's about, you should understand the way that it thinks of features and characteristics. That is at the heart of QIF. So what is a feature? A feature is a way of abstracting some portion of geometry, really for any particular reason that you might have. So to look at this case in the abstract, this is a cylindrical hole, and as you can see, it's made up of two faces. So it's a pretty typical situation. But what that highlighted yellow portion is that's saying this is one feature. It's a whole feature. It doesn't matter if it's made up of two faces or five faces or one face. It's irrelevant. This is one logical unit, which is a feature. And in this case, the reason for that feature likely is that there's a position tolerance pointing to it, and a size tolerance pointing to it. And that's why that feature exists. But this is a very core idea, is abstracting away a little bit from what the CAD definition of a particular surface or set of surfaces might be, and looking more to functional purpose of something, aka a feature. And so QIF has a rich taxonomy of different feature types, which you could find out more about if you look at the QIF standard. And then the next idea is this characteristic. So this is how this idea of model-based characteristics is implemented in QIF. Again, there's a rich taxonomy of different types of characteristics in QIF. They might be tolerance, sort of GD&T related, maybe it's surface finish, welds, user-defined characteristics. And the core idea is that a characteristic on a part points to a feature, and then a feature points to its underlying CAD surfaces. this right here is the essence of how QIF is architected from an MBD perspective. And this right here also is the essence of how model-based characteristics should be instantiated. And this is how the ideas of model-based characteristics is being instantiated, is with this core concept right here. So that's a little bit of background just about the general ideas of model-based characteristics, how model-based characteristics can be implemented in QIF. And Evan now is going to talk a little bit about some of the real application-specific areas and how these workflows look.
Perfect. Thanks, Daniel. Let's see here. Share my screen. All right, you able to see my screen? Okay. So next, we're going to talk about the enterprise. So Daniel did a great job of talking about model-based characteristics, QIF, and kind of some of the gaps that we have within the industry today. And we're going to walk a workflow. But before we get there, I want to talk about a couple of things, and that is enterprise technical data exchange that's occurring today within your enterprise. And this is a look at a contrived model-based enterprise. It's made up of various different domains that represents lifecycle activities from concept to disposal. So we have domains like engineering, and then we have our consumption domains, which are made up of manufacturing, quality, sustainment, and an extended enterprise, which is your supply chain. The goal is using model-based definition within your engineering domain, or you may even be creating in-process models within manufacturing and sharing that downward as well. The idea is that you want to exchange this data and all of the elements of model-based definition. But now what we're talking about is including and adding model-based characteristics and even all of the augmentations that Daniel was just talking about. So whether this data is being created within your engineering domain within the native CAD, or we're going to talk about where QIF can fit into accept the data from your engineering domain, your native CAD, or even creating model-based characteristics through a QIF workflow, and then being set up to exchange this data to your downstream domain so you have persistent, traceable data throughout the product's lifecycle. Now, when we think about a technical data package, right, a 3D data package, this is a made-up definition being very closely coupled to standards. I feel that the standards within ASME and even Military Standard 31000 need to be, they need to adapt. And I think that there's some key attributes that I want to talk about here for a data package, and that is that the data needs to be authorized. It needs to be trusted, validated. It needs to have complete definition across all of your product definition. It needs to be interoperable, traceable, and human readable for all of the consumption workflows within your enterprise. And so what does it mean to be human readable, interoperable, trusted, and traceable? And I don't want to talk about this in the context of all of model-based definition because that would take a long time. But let's talk about it in the context of model-based characteristics. And Daniel did a great job of teeing this up. And we have two model-based characteristics or product characteristic tags. So I have a PC10 and a PC11. What makes this data human readable? And that is the graphical representation that I can see this tag. It's within close proximity to its requirement, my pattern, my feature of size dimension. And I can use my human brain to make that connection that PC tag 10 is associated to this pattern of 4 holes for the size tolerance. But what about our downstream systems and tools, right? What makes it machine readable or interoperable? And that's where we need some metadata or attribute structure or framework. And this is where the gap that the model-based characteristics 1.0 standard is filling. within that standard, it tells us that we need to have some attributes, some metadata that says that what is the PC tag, right? So in this case, my PC tag is going to be PC10. Do I have a UUID, right? So what is my universally unique ID to make it stand on its own? I did see a question in the chat, and that UUIDs today are an optional thing within the standard, but if you want data traceability and for your characteristic tags to stand on their own within your enterprise or within the universe, you need a UUID. And then what is my product characteristic tag associated to? In this case, it's associated to this annotation, and I would have that annotation named there. What makes it trusted, right? It needs to be compliant to industry standards. It needs to be semantically complete. It needs to be universally unique with a UUID, and it needs to be verified through some type of a checking process, right, for it to be trusted data. And then data traceability happens as it's being consumed across our enterprise, as it's being consumed and reused within engineering, manufacturing, quality, and supply chain, right? We're all reusing this same data, the same product characteristic with the same UUID. It's persistent throughout the life cycle. And one of the things that Daniel said, which is really good, is that we now have data traceability at the atomic level, which is now at the characteristic level. If you stop to think about that today, we usually have data traceability at the part level, or maybe at a serialized part level. Now it's down to a characteristic within your part, right? A piece of PMI, and that's great. There's a couple of two different types of model-based characteristics that I want to talk about. The first one is our product characteristic tag. That's the PC15 that you see on the screen here. I also like to call those our parent tags, or many of you call them balloons. And those are being assigned to each requirement or characteristic within our model, or MBD. And you could think about this as being assigned to each requirement as it stands on its own, like for a size, dimension, and position tolerance. But in some cases, for patterns, we also have a product characteristic instance tag, and these are the child tags or the child balloons, and these are the PC10, and then it has a dot with its instance. So for my pattern of 4 holes, I have 4 instances for both the size dimension and the position tolerance respectively. All right, and once I've characterized my MBD properly down to the instance, I can now generate a bill of characteristics, which has a lot of great information embedded inside of it. I have all of my product characteristic tags. I have the presentation state that it resides in. I have its requirement as it's stated within my model-based definition. And then I have it broken down by nominal, plus minus tolerance, and even my datum reference frame if I wanted to filter or sort by the various different setups that I may have. The nice thing about a bill of characteristics view is that A, it's characterized, and you can see a lot of your requirements all at once. And I think one of the shortcomings that, or a hurdle that individuals face when transitioning from drawing-centric workflows to model-based is that you only get to see one presentation state at a time. In a 2D drawing, you may be able to see multiple views at a time. But in a bill of characteristics table, you get to see a lot of information across the entire table. So traditionally, right, in a drawing-based workflow, how are characteristics assigned? Where are they created? In a drawing-centric or drawing-based workflow, engineering creates a 2D drawing. That's usually accompanied by a 3D model. And as that data gets released, some data may be exchanged or into a PLM, but quality is going to manually balloon or characterize this 2D drawing. Keyword is manually. And then once it's characterized, they'll manually generate a bill of characteristics, whether they manually transcribe that into an Excel spreadsheet or they manually transcribe that into some database downstream to perform lifecycle work activities. Manufacturing will manually reuse this, and then inspection, it gets manually transcribed into their inspection software. So if you think about where is characteristics actually being assigned, it's by a human in the quality domain downstream, out past release, which is very error prone and time consuming. In some cases, an alternate option would be to those characteristics are being assigned within the inspection domain. If we look at a model-based workflow, I have two of them that I want to show you, where today we want to characterize our data within engineering. And I put partial characteristics here because there are some shortcomings and hurdles with the current state of tools to characterize our product definition within our native CAD. And then complete characterization is happening within this enterprise data workflow that we'll talk about here in a few minutes. So we have our model-based definition where we're characterizing our MBD, but only at a parent level, okay? So that's going to be that product characteristic tag level. Through an enterprise data workflow, we'll generate QIF where we'll reuse that parent tag within the native CAD. So extending that thread across, including the parent ID tag. But we'll assign those instances. Okay, so we'll decompose that down into the instance level, assign those UUIDs for instances, and then generate the bill of characteristics in addition to a visual data package. From there, now we're setting up the enterprise, our consumption workflow or consumption domains for the ability to reuse this data, right, for automation, data traceability. But obviously, I want to make note here, our nirvana state is that we want all of our characteristics up front in engineering. But there's some significant hurdles. And I think that model-based characteristics is fairly new to the industry. To be able to characterize and decompose patterns is a challenging thing. And I think standards, one of the things I'm working on within the ASME standards committees right now is that decomposition of these patterns, so we can help support these types of workflows. And then the next one is where we're not authoring any characteristics within our native CAD, where this characterization is happening within our enterprise data workflow. And that is an acceptable approach. I think it's more of an interim approach until these tools are more mature to characterize our data within our native CAD. So you can see that I have uncharacterized data within my model-based definition. And then I'm assigning both parent and instance tags within our QIF workflow, and then we're exchanging that data downstream. Here's a closer look at that. So here's the partial characteristic. So here's what it would look like with the PC tags in our native CAD with our metadata structure that accompanies that, right? So this is my human readable portion, and then I have that metadata structure to ensure that the machines and tools downstream can also have that same. But when we translate this to QIF, right, we're going to harvest that geometry. We're going to harvest all of the PMI and its attributes and metadata. We're going to reuse and harvest the parent characteristic tags, but then we will augment and we will assign those instance tags because that's not there. Once we generate the bill of characteristics, we now have that complete characteristic assignment that's happening within our QIF workflow. The difference here in the next one is all of it's happening within our QIF workflow. And this is something that can be done today. QIF is a very mature tool. QIF MBD has been around for quite some time. And once you export that QIF, you're going to harvest the geometry, all of your PMI and attributes, but now we can assign those parent tags and then also all of our instance tags to generate that bill of characteristics. All right, so let's take a look at a workflow. So next, we're going to actually walk this workflow. So I'm going to showcase the only CAD tool that has the ability to characterize your native CAD, which is NX. And they do a really good job of characterizing that data. So if any of you happen to be using NX, get yourselves a version of 2506, and you'll be able to characterize your data. So we'll take a look at that. We'll then show a QIF workflow and how that's being extended from your native CAD into QIF. We'll take a look at a visual technical data package that showcases these characteristics, showcases the bill of characteristics, and allows you to visualize that data in addition to, that would be the human readable portion, and then the ability to attach your interoperable data sets like QIF Step 242 to this technical data package to then extend to your downstream consumption domains. So within NX, we have NX Inspector. All right, so directly within NX, there's a ribbon called Inspector where you have the ability to generate characteristics. All right, you can show those characteristics, turn them on and off, and you can publish them directly to Teamcenter, which is great. Characterizing your data is really easy. You can start your indexing. So I'll start at 1, and then I'm going to select all the PMI within this view, and then I'm going to hit Apply. So characteristics are off by default. I'll show you that here in the next view. So I'm going to go ahead and characterize again, make sure my index is correct. I'll select all of the PMI within this view, and then I'll hit Apply. We can visualize these characteristic tags. So there it is. We have our PC tags in the text-based symbology that the model-based characteristic standard allows. And there is a characteristic navigator that I don't show in this video, but I do have a slide next that I'll show you, where you can see that for this PC tag 10, I have my characteristic navigator. And in the latest version of NX Inspector, you have the ability to do instance tagging as well. But there are some limitations with that, depending on modeling practices and using the whole callout tool. But here's a look at that. So in the characteristic navigator, we have our PC tag 10, our UUID that's being assigned. And then as we export that to QIF, you can see that that data is being harvested and reused. So we have our designator, which is the PC tag, the parent tag, the UUID. And then this is being decomposed into instances within the QIF workflow. So here I have my PC tag 10.1, 2, 3, and 4. And you can see kind of how the digital thread is being extended from our native CAD beyond the normal geometry PMI. We're now taking characteristics into our QIF format. All right, and now that's giving us the ability to do that traceability at that atomic level. Next, we'll generate a QIF. That's really difficult to show. It's kind of boring. But what we can see and visualize is the validation of QIF, right? So here is a validation report. It's using NX, and then we have QIF. I have access to all of my MBD elements, but what we're after today is just to showcase those PC tag elements and metadata making its way across, right? So I have access to my views, and I'm going to activate all of the PMI, and then I'm going to select a specific annotation. And then you can see here that in NX, I have a PC tag 6 with a UUID, and that was translated across into our QIF. All right, so you'll be able to validate that this data is persistent across. So I won't spend any more time on that one. Next, we'll take a look at a data package. And again, this is a visual data package. It's using a 3D PDF. There's also technology with using HTML, but it's this is the piece of it that is the human readable piece, but also we're containing those interoperable formats like QIF, step 242. You can even extend or attach native CAD and 2D specifications, whatever is needed for your data package. So here's a look at that 3D PDF. So again, it's human viewable. You can rotate the model. You have access to all of your annotations. We have our bill of characteristics, access to all of the presentation states within the MBD model. There's access to notes. In this case, our notes are characterized and they show up here on the screen with those characteristics. And then we have our attachments for that, extending that for the machine readability portion of this. So all of our attachments can be downloaded. And then we have our bill of characteristics. So here I actually have the parent. So you can see that it has a pattern of 4x. You can see that here, all of its associations. And then it might be a little difficult to see. I should have zoomed in more, but I have my instance. So you can see my PC tag 10.1 and this one's 10.2. You can see those tags highlight and show you which what that tag is actually associated to. You can rotate that model to see those associations a little bit better. But think about the old way of doing it. Now we've just created characteristics tags automatically, and now we're able to visualize those through a 3D viewable, which is great. In addition to having access to all of our bill of characteristic information, you can sort this information. You have access to your PC tags, the views, and then all of the requirements. Why? Why would we want something like this? My past background is in engineering. I've been a releasing engineer in the appliance industry for the majority of my career. The latter half of that career, I was doing model-based. And I think the struggle is that there's a distinct boundary or silo at many organizations where data is being created and you just hand it over the wall. And I think that there's some great use cases around a bill of characteristics style view that uses model-based characteristics that's being derived from our QIF. And the first one is that it's human readable. The humans in our model-based enterprise are a big part of our enterprise and always will be. So I can visualize the bill of characteristics table, and I can visualize my characterized PMI. If that's not enough, right, you can ensure that your PMI is being decomposed properly, that your PMI is characterized properly through the viewable. And I think that this is a big one, that as you're reusing your QIF in downstream tools like metrology, you can ensure that it was imported properly. You can bring manufacturing quality to this design review table. And I think that every organization be accepting to that viewpoint if you don't already do that today. So I think the bill of characteristics style view helps support that. And then obviously it supports with quality planning, with inspection planning through the bill of characteristics. And then the next thing is, let's reuse this data, right? Let's reuse this data within our downstream consumption domains. And I'm going to view this through the lens of inspection, right? And I think that that's one of the most mature workflows for reusing QIF, right? And we're going to show how we've extended from our native CAD into inspection through the use of QIF and our data package. So this is a look at Polyworks Inspector. All right, they have a QIF import, and many other metrology platforms also support QIF, and I have a list that I'll show you here in a few minutes. I'm going to import my QIF, and it's going to import all of my geometry and all of my MBD elements, including characteristics. So I have access to all of my characteristic tags, both parent and child characteristics, or those instances. I have the characteristic name and their requirements. I have access to my presentation states. And again, all this happened during that import process. There's no manual transcription that's happening here. There may be some corrections. And then I have my measurement features. What are we actually measuring? For this pattern of 4 holes, I'm measuring 4 cylinders. What are the requirements for each cylinder? Well, I have that here with my instances. All right, so you can see the PC tags are actually associated to each hole. Here's a good look of where the viewable can be used to verify, right? During any import process, there's a translation that's happening. Doesn't matter what derivative you're using or native CAD, there's a translation that's happening. And it's always good to verify that as you're importing your data into another tool, that you can verify that. And I think the human viewable, this 3D PDF that's derived from QIF with the bill of characteristics, makes that really easy for you so you can visualize those instance tags. So there's many platforms that support QIF, that support characteristics. And so I encourage you to, if you work with some of these, that I encourage you to have a conversation with them around QIF. Do a pilot. QIF is very mature, and especially now that there's tools out there to author characteristics within your native CAD, third-party tools, and a few native CAD. And you can see how that data can be extended across. So Polyworks Inspector, Metrologic, PC Demus by Hexagon, Calypso, Evolve Smart Profile by Codem, Verisurf, and I'm sure there's others that I did not capture here. So here, you can see how we've extended that digital thread. Using model-based characteristics that were authored within your native CAD, those were augmented within a QIF workflow, verified into a data package to extend that data to my downstream domains, consumption domains for both the human and interoperability piece, and then consumed within one of my quality workflows for inspection. So we'll open it up for questions. So thank you very much.
Thank you. That's great, Evan. So we do have some questions that came in. One of them, a common question is just a question about the recording of this webinar and the slides. And the answer is yes, those will be distributed. I think they'll be emailed out and put on the website. You'll get some email notification about that. Yeah, so maybe, Evan, we could just run through some of these questions. If you have questions, please do put them up in the chat.
I have not reviewed them all yet, but I will. Yeah, if you could read them off,
yeah,
or if you're ready.
Yeah. So one question was, should the product characteristic tag be unique? Yeah, I mean, I answered that one. Yes, I mean, according to the standard, it should be unique. It's important that it's unique, obviously. The balloon, like the PC tag itself, that balloon number, let's say, that should be unique within the part. And then if a UUID is employed as well, UUIDs should be, by definition, universally unique. So, let's see. There was a question about, actually a question, a good one for you, Evan. If the instances being in QIF, like if there are instances in QIF but not in NX, does that come over as a discrepancy in the validator? So I guess if there's a mismatch between characterization and QIF versus NX, let's say.
Yeah. I think as long as it's understood in the validation tool exactly what parameter we're after, that's going to be used to harvest that information. Yes, we can check for that discrepancy.
Okay. Yeah. I mean, here's a good practical question. Evan, good to hear your thoughts. How can we effectively implement a QIF workflow given the dual challenges of needing 2D drawings for decades and also having a QMS that's limited to non-QIF proprietary files? So how to navigate those couple of challenges? maybe at first you could, the question of 2D drawings, right? I mean, they're here to stay. So what are your thoughts on QIF, model-based definition, and 2D drawings?
Yeah, I think that, I mean, in my past life, we dealt with, it's hard to build an entire new product that's completely model-based, right? So you're going to have a mixture of drawing-based and model-based to make a complete product in most cases. So yeah, I think there is a challenge with having the same level of automation, data traceability, all of that back to a 2D drawing, but there are technologies out there with optical character recognition and those such things to characterize drawings. When it comes to your QMS, I mean, I think for a digital transformation, I think a part of that transformation is the tools and systems that you're using. And so a quality management system, if you're going to onboard QIF, it might be a good idea to look into tools that can accept that, to easily exchange that information. But I don't think that should stop you from at least piloting or looking into QIF to understand the true benefits to your organization.
Yeah, the other thing I was going to comment on that is just that QMS systems typically try to be able to pull in data from any number of sources, because you might have all these different measurement devices. So I would recommend talking to your QMS software provider about QIF and tell them that that's a part of your ecosystem and that you'd like to see support for that. If it's the case that QMS doesn't support QIF, actually it's pretty easy. It's pretty easy to support it, and a QMS system might welcome it because it's a way to get data in from many different types of devices. So, there's a question about integration with CAM, and yeah, there are some CAM softwares that are working on implementing QIF. Often a big question is what what's the workflow for a CAM software to use MBD? But there are things out there, definitely. A lot of there's a lot of groundbreaking technology in the area of correlating inspection data with CAM programs for corrections and things like this. Also, just in terms of traceability, data traceability of MT Connect data that comes out the back end of a DNC execution. I don't know, Evan, if you have any thoughts on that question.
I think you answered it well. I will pick on or we can talk through the QIF. Can QIF distinguish between requirements of separate versus simultaneous requirements on patterned features? I'm not sure that, I think all of the data is there to understand simultaneous requirements, but to me that feels like something that would happen within your downstream metrology tool to enforce simultaneous requirements. But I don't know, if you think about QF 4.0, Daniel, which you're involved with heavily, is there a mechanism on the horizon to help with that, or a schema to help with simultaneous requirements?
No, I think you're right. I mean, that is already baked into QIF. I mean, the current version of QIF, QIF 3. But you bring up a good point, which is whether any given software, decides to implement simultaneity correctly or not. That's up to the software. And so I think it is important to remember QIF is a data format. It doesn't do anything. It's not a software tool. It's the data format, and then you use software tools to do things. But yeah, I think your answer is right, Evan. Yep.
And I'm just picking these kind of at random. So can PC tags be assigned to Class A surfaces? I think the short answer is that product characteristic tags can be assigned to anything, anything that you really want to track. Now, how what requirements are associated to that, or how you verify something like that. But I don't think it really necessarily needs to be a measurable item. It can be associated to anything. I don't know if you have any thoughts on that.
Yeah. Sorry, I was reading another question.
Oh, it's okay.
But yeah, no, I think your answer is probably good. Yeah. Let's see here. Yeah, okay. I mean, here's a question about QIF. I think, and it's probably a big picture one related to like, well, how does QIF fit? So is QIF data authored on the model? And then does that mean that downstream tools are just viewers trying to understand the flow? So, I mean, let me give a couple thoughts on this. QIF is so it's called the Quality Information Framework because it's actually meant to be, you don't even necessarily need to think of it as one file or something like that. You can have a set of files that are all related to each other. They point to each other and they build on each other, let's say. So a typical workflow might be that you create a QIF MBD model, which is a derivative of your native model, the same way that STEP or IGES, you have a QIF model that corresponds to that. That could be consumed by your CMM software, let's say, and then your CMM software starts creating other files, which are results files. And that builds on top of that QIF MBD file that you had. So yeah, I don't know if that helps to answer that question a little bit. Evan, if you have any thoughts on that, like QIF across the enterprise.
Yeah, I mean, I think there's a lot of use cases for QIF, and obviously I think you are visualizing it in many cases, but you're using it to extend, your MBD elements, features, characteristics, everything that QIF MBD provides into those workflows. But you're right, it is now a container with QIF results. You can do a lot with it, and that's a part of the QIF wheel that Daniel talked about at the very beginning, and all of the I can't remember what that's exactly called, but yes, there's a lot you can do with it more than just
the
visualize.
wheel. Yeah. Oh, here's another question for you, Evan. So is Siemens NX the only program that can export GD&T annotated parts as QIF, or do other programs also exist which allow this export format? So is QIF available for other CAD?
Yeah. So I mean, QIF can be exported from all native CAD platforms.
Yeah, so here's a question, and actually there were a couple questions that were along this line. In one of the slides, there was a picture of a characteristic that had all around. It was all around or all over or something like that. And so the question is that information included in the characteristic? So I would say the answer, or the answer is it depends on which level you're talking about. So is that a part of what's talked about in model-based characteristics? Not exactly. Model-based characteristics is more about tracking the characteristics. But whether that's included in QIF, absolutely. There's sort of a semantic understanding that this is an all around or an all over. And so I guess just in terms of these DMSC standards, I mean, that this speaks to the relationship to MBC and QIF, which is that MBC is more about principles for managing characteristics, and QIF is really a data format. Maybe we can get to one more. There's a question here from Ben. I don't know. It might be more detailed than you'd be ready to answer here, Evan. But do you happen to know the? Do you happen to know the how characteristics from NX, for example, how they are manifested in STEP AP242?
Oh, I don't have a good answer for that. We should be asking Ben that question. But I think that the industry is working on that right now. I think that the concept of, I mean, correct me if I'm wrong, but I think the concept of characteristics is not there within STEP today. As a custom attribute, can that data be, authored into STEP? Yes, but to do what? You're right. To what tool downstream is going to be ready to read that? So, I don't know. I don't have a good answer for that. I think that the concept of characteristics and the concepts of features and UUIDs and all of that is needed across all of our neutral formats.
Yep. I mean, I've been to close on that thought. I agree, and I think that there's definitely a good industry drive heading in that direction. where, like I said, industry is starting to recognize the importance of managing characteristics as, you know, semantic entities of data. And so we're seeing this across, yeah, the QIF world, the STEP world. And so, yeah, that's the way things are going. So
Daniel, one last question came through, and I think it's around QIF and being able to manage that data, right? If we're augmenting and adding characteristics or designators in a QIF workflow, it says how to make the loop back so changes QF or as changes in the design. And there are mechanisms in place in workflows within QIF to have change control, to understand and keep those characteristics persistent across engineering changes. So that's happening today. So you can take advantage of that to keep that data persistent.
Yep, it's a great question. Yep, and that's exactly the types of questions that that we need to be asking, is thinking along these lines. So
Great.
Well, anyways, yeah. Oh, Mark, yeah.
Yeah, okay. So basically we want to finish up here. Daniel, Evan, we want to thank you for sharing your experience and knowledge on this important topic. Those of you who did attend today will be getting a thank you note for attending and so on, and that is where you'll find most of the information that Daniel was talking about earlier regarding availability of both the slides and the recording that we're just finishing up here. So, gentlemen, thank you very much. We certainly appreciate it. And certainly all of you that attended the webinar, we appreciate that as well. So thank you very much. Take care now.
Thank you, everyone.
Thank you.